Today we're going to look at finding the zeros of a polynomial. And this should be a little familiar to you because we've talked about finding zeros of other functions. We know that the zero is where we cross the x-axis. So we're going to say where the graph crosses or touches. Sometimes it's not going to go all the way through, but it's going to touch the x-axis. When we identify our zeros, we use our x values only. And we can also call these like solutions or roots. They're the answers. They're where the problem actually equals zero. So we also know that sometimes we get multiple answers that are the same when we solve equations. Like sometimes x equals 3 2 times. So when we talk about that, or when we see that in a graph, if we have one answer showing up multiple times, that's when we're talking about the multiplicity. So multiplicity is how many times a zero is a solution. And we have three different situations there. We could have a multiplicity of 1, we could have a multiplicity of 2, or a multiplicity of 3. If we have a multiplicity of 1, so a multiplicity of 1 just means that my graph is going to cross right through the x-axis. So my zero is going to look something like this. A multiplicity of 2 is when my zero bounces off of the x-axis, so it's something that looks like this. And a multiplicity of 3 is when our zero crosses through the x-axis, but as it does, it flattens out and then keeps going. So it looks like that. It's not just going to pass straight through. It kind of hits the x-axis, flattens out, and then continues on through the x-axis. So we're going to look at different graphs and picking out their zeros and telling what their multiplicity is at that location. So if we look at the first one, identify the zeros and their multiplicity. I see right away I have a zero at -2, I have a zero at 1, and a 0 at 3. So my zeros, x equals -2, x equals 1, and x equals 3. Because my zero at x equals 2 bounces off my x-axis, it looks like a parabola. That is a multiplicity of 2. That means that if I was solving this equation, if I set this equation equal to 0 and solved it, I would get the answer x equals -2 in 2 different places when I was solving. 2 of my factors would give me a solution of x equals -2. Then when I look at x equals 1, I see that that passes straight through the graph. So that means we have a multiplicity of 1, because it passes right on through. And when I look at 3, it passes straight through again, so that's also a multiplicity of 1. So you can have any sort of combination of multiplicities. Sometimes they may all have a multiplicity of 1. You might have one that has a multiplicity of 2. You don't have to have all of them, and you can kind of have any sort of combination of them. So you're just looking at each specific graph and each specific root in order to decide what's happening. So if I give you another example, I could say, identify the zeros and use their multiplicity to write the equation. So first, let's pick out our zeros. Let's also pick out their multiplicity. So I see my first 0 is at x equals -4, and since it passes straight through my graph, that has a multiplicity of 1. My next 0 is at -2, and since it's at -2, it bounces off the x-axis. Even though it's facing down, that's okay. It's bouncing off the x-axis, blah, blah, blah. So that means it has a multiplicity of 2. And my last 0 is at 3. Because it passes through the x-axis at 3. And when I look at it, now I see that it's approaching 3. It starts to flatten out, and then it keeps going. So because it starts to flatten out right on the x-axis, that means that my x equals 3 has a multiplicity of 3. So now, because I know what my zeros are, I know that my original equation of this graph is going to have all of these factors in them, and the multiplicity tells me what their exponent is going to be. So I'm not sure if this graph is stretched or if it's shrunk, so I'm going to leave an A there because I can solve to find out if I stretched it or I shrunk it at all. But then I know that if I got a solution of x equals -4, that means I had a factor of x equal plus 4, because x plus 4, if I set that equal to 0 and solve it, that'll give me x equals 4, -4. X equals -2 tells me I'm going to have a factor of x plus 2, and x equals -3 tells me I'm going to have a factor of x minus 3. After I write my factors, then I go back and check and say, okay, at -4, I had a multiplicity of 1. So my exponent for that factor is 1, which I don't really need to write because we don't write exponents of 1. At x equals -2, my multiplicity is 2. So that means my exponent for that is a 2. Then when I look at my last factor, x equals -3, my multiplicity is a 3. So my exponent is a 3 there. For now, you can leave this A, just knowing that we may have shrunk or stretched the equation in some way. So we're going to leave it as just an A there for now, representing that we could have shrunk it or we could have stretched it. And when we meet in class next, we will talk about how to find that and look at zeros a little bit more in depth. But today you're just going to pick out the zeros, pick out their multiplicity, and then use their multiplicities to actually write the factored form. So this is called the factored form of the equation.